Okay, good evening, everyone, and welcome, and thank you for joining us tonight for a Temple Engineering session on the Department of Electrical and Computer Engineering. My name is Colleen Bailey. I'm the Director of Enrollment Management here, and tonight you'll have the opportunity to hear in a little bit more detail about the department. You'll hear from some of our faculty and one of our current students, as well as have the opportunity to ask questions of them as well. Please hold all questions until the end of the session, and we are also recording the session so you can view it at another time. So again, thanks everyone again for joining tonight. This photo here was obviously taken pre-COVID times, but we're looking forward to getting back to campus soon. Tonight joining us, we have 4 of our faculty members, the chair of the department, Dr. Lee Bai, Dr. Brian Thompson, Dr. Corey Budishak, and Dr. John Helferty. And we're also joined by one of our current students who's a senior, Mark Olivetti. Dr. Bai, did you want to say a few words?
Yeah, I just want to welcome everyone. Thank you very much for coming at this time. And I know it's difficult, everyone sitting through all the Zoom meeting. So this is great, and good. Hope to see you guys all in next fall.
Great, thanks, Dr. Bai. So just real quickly before we get into the department, just talk a little bit about Temple. So we were founded back in 1969, so we just celebrated our 50th year, which is very exciting. And the College of Engineering has a little over 1,700 students, and that includes both undergraduate and graduate students. So we have about 1,500 undergrads and just shy of 200 graduate students. And that's a good number to consider too, because when you compare the College of Engineering at Temple, Temple's a very big school. We have almost 40,000 students with us, and we're one of the biggest universities in Philadelphia. The College of Engineering is pretty small by comparison to a place like the School of Business or the College of Public Health. So what that means for you, and you'll get to hear about that a little bit later from our student and from some of our faculty, is really the opportunity to get involved with lots of neat things with the College of Engineering, either with faculty research or with internship opportunities. It's got all the benefits of being at a large major research university, but you still get the small school feel at the College of Engineering, which is great. Our total population, our undergraduate population, is about 25% female, which is above the national average, which tends to hover around 21–22%. We also have a highly diverse student body. About 37% of our students are non-white, and we have international representation as well. About 136 of our undergraduate students are international, representing countries throughout the globe. As for the Department of Electrical and Computer Engineering, there's a little under 300 students in the department, about 250 undergrads and about 50 graduate students. And you can see they're kind of the numbers here sort of mimic the College of Engineering as a whole, with about 18% female students, 35% students underrepresented, and 37 international students. So that's just a little bit about the department. Now I'm going to turn it over to some of our faculty who are going to talk a little bit more about some of the research they do and some of the opportunities that you have as a major in electrical and computer engineering and as a student as well. I think I'm going to turn it over to Dr. Helferty first.
Okay, sure. Thanks, Colleen. Pleasure to meet, have everybody here tonight. Colleen, can you start my video?
I don't think there was a video.
The host, well, the host has stopped the video. I mean, so they can't see me. Okay, well, either way, what I'd like to do is just to let everybody know, I'm an alumni at Temple University, just like Dr. Lee Bai is. And I graduated in class of '83. Dr. Lee Bai, I think, was the class of '96. And so we go back a long ways. And what I'd like to show you is some of the NASA-supported ECE projects that we have that are outside the classroom. And these are things where we take the technology that we learn in the classroom and move it out into specific projects that are NASA-supported. And one of them is, if you click, Colleen. All right, so we do it this year. We're doing the for the 11th year, the robotics club that supports the robotics mining competition at Kennedy Space Center. We take a trip down every year. This is one of the groups that was back in, I think, 2011. And what we do is we go down to Kennedy Space Center and we compete against the top 50 teams in the country to do robotic mining. Please click. We also do suborbital payloads that are launched out of NASA Wallops Island down in the eastern shore of Virginia. We've been doing this since 2009, and we have suborbital payloads that actually get NASA certified. We work with NASA engineers to get the actual payload certified and get it onto a actual NASA rocket. Next one. We do high altitude ballooning experiments, which with the last major one that we did was a solar eclipse on August 21st of 2017. We ventured down to Russellville, Kentucky to get the path of totality. And we were actually part of 40 teams from across the country that were streaming the solar eclipse from over 90 to 100,000 feet up. Next one, please. We do autonomous quadcopters. This is actually some of the things that we started in our freshman class with handheld quadcopters, and then we migrated over to autonomous quadcopters that are sent out into the field to do all kinds of things like wildfire management, just inspections of infrastructure and things like that. Next one, please. And approximately in the lab, I get around 30 students involved each year. And these are things that you want to do outside the classroom. And it is one of the greatest experiences is to take the things that you're learning in the classroom, whether you're in freshman year through senior year, and actually get involved in building things that are related to the technology that we have and that we're teaching you in the classroom and actually building things. So please move forward, Colleen. This is actually the rocket that we launched out of Wallops Island. It's 60 feet to the tail. The red section that you see at the top here is the payload section. The two lower parts that are white and yellow, those are the actually two-stage Terrier Orion 2 rockets that we launched. Next one, please. And that's actually at 5:30 in the morning. You're sitting there, you're having your cup of coffee, you're 300 feet away from this thing, and you get to watch this rocket go up and hit suborbital suborbital around 63 to 67 miles up is where we're targeting. Next, please. And this happens to be a T in the center, Matt on the right, and that red section I mentioned in the previous slide was this payload. We all get to sign it. There's different teams that are all actually also involved in it. And it has a couple of ports on it that we use for using spectrometer experiments to go out and see what type of, let's say we're looking for CO2 gases, we're looking for nitrous oxide and things like that. But this is the payload, and this is where we do the integration. And you can see the rocket is on the back left over my shoulder, and we go down to Wallops Island for 9 days to do these experiments. Next slide. This was a team that followed the next year. And if you would be kind enough, Colleen, to click on the top link, I just want to give everybody a view of what the rocket looks like.
Bear with me here. I have to stop the slideshow real quick.
So just copy that link and bring it on over.
Is it playing?
No, I think you stopped sharing, so you got to share.
Yeah, you got to share. Just share.
Okay. It looks like you have to make me the co-host again.
Ah, yep.
Done.
Okay. Corey, you could turn my video on too if you want.
Yeah, I think you have to do that, John. I don't think it'll let me do it, but I think you should have the
There we
ability.
go. All right,
Yep,
cool.
there you go.
There we are. Thank you.
There we go. Hopefully everybody's able to see that now.
All right. So if you want to wind that back a little bit, please. All right. So we're sitting here at Wallops Island. It's 5:30 in the morning. The rocket is on the launch facility. This takes a year to go through all the testing. This is a slow motion. So here's phase one of the rocket. It goes for about a 2.5 second burn. And now you can see the rocket spinning because it's spin stabilized along the Z axis. And then it goes for about a few more minutes, and then the second stage kicks on, and now we're ready to head up the suborbit. And I tell you what, if you're a student and even a faculty member, this is where your heart is beating. You're just hoping that rocket just keeps going on and on all the way up. And we're going to hit suborbital, and then we're going to get a payload that's going to come back on a parachute. It ends up about 60 miles off of the coast of Virginia, and it's recovered by a boat that comes out, our Coast Guard cutter. Okay, you can go back to my slides. And anybody, if you have any questions at any time, please let me know. Click on the next one. No, you don't have to do that YouTube one. Just go to the next slide. That was just another YouTube slide. Thank you. And these are completely funded by NASA. So you don't spend a dime on this. This is stuff where we take you and we transport you to Kennedy Space Center or to Wallops Island, or in this case, we went to the Solar Eclipse project. Now, Mark, who's going to talk to you in a little bit about his high altitude ballooning experiment, we were fortunate enough to get funded by NASA to go out and do the solar eclipse on August 21st with other teams that were sent all across the country. Next slide. So if you remember, the path of totality went from all the way up in Oregon, all the way down through Columbia, South Carolina. We decided to get the path of totality in Russellville, Kentucky. And that's where you see these teams that are bundled up in here. And if you hit the next slide, this is the system that we had built. It's comprised of a radar dish. We have the Eclipse going on. We have GPS satellites transmitting down to our radar dishes. We have an Iridium satellite that's going to go down and actually send and transmit down video and still pictures that are going to come back to two. One is a patch antenna and the other one's a Yagi antenna. And then we transmit that through our ground tracking system on a laptop that goes out to the web. And it was one of the most unbelievable experiences that I've had in my 34 years of teaching. Next slide. That's the actual dish that we built and had to be tested with the radar dish in the center, patch antenna, and a Yagi antenna on the right. Next slide. And that's just a description of what it is. So Mark can tell you a little bit about this later, right, Mark?
Yeah, for sure.
He's doing it this year as far as his senior design project. So next slide. All right, so this is down in Russellville. We're down in Kentucky. It's baking out. It's 95 degrees out. We have our team of that's sitting down there. Next slide. And that's what a high altitude balloon looks like. The Kentucky balloon is sitting behind us on the right. We're filled up with our helium tanks. Fill this balloon up. There's a parachute here. There's a cutoff system that is right here that my wife is actually holding. And the next systems that are down here are actually the payloads, the Iridium satellites. And the one that you see down here is actually the camera system that we have. Next slide. We got up to the jet stream and we're looking at this live. So we can see Kentucky's balloon is over here on the left. And lo and behold, there's an airplane coming around. So we caught a jetliner actually going by us at 35,000 feet. Next slide. And there is the Eclipse. That is looking at the balloon. The camera is sitting down below, rigged up to these four little supporting systems. And that is what the Eclipse looks like at 100,000 feet with a Raspberry Pi camera. Next slide. The balloon eventually goes up. It expands on the way up because we're getting into lower air pressure. And the balloon finally explodes. And that's where you can see the balloon exploding. And then at that point, the system starts to completely fall down. And we jump on our vans and we use a tracking system to go and recover the payload. Next slide. All right, this is the robotic mining competition that we do at Kennedy Space Center each year, except for last year under COVID, but we're on our way to do it this year. We build robots that actually mine lunar regolith. They have lunar regoliths sitting down at Kennedy Space Center. There's approximately 40 to 50 teams that get in there and compete each year. And Temple's been fortunate enough to work since day one on this. I was fortunate enough to get in and design this competition, and it has been fantastic. We bring about 8 to 12 students down each year, and they get to compete at Kennedy Space Center. Next slide. Go to back, the last one. Just back one more. There we go. That's the one. That's what we built this year. You can see that there's an auger system on the front of this that's going to tilt up and dig down so we can get subsurface ice. That's the big thing that NASA wants. They want to get ice because it has hydrogen and oxygen in it. So the deal is you've got to mine subsurface ice. We have 4 wheels on this system. We have a conveyor belt to pick the stuff up and bring it back to dispensing bins. But this is the real deal. Some of you high school students may have dealt with FIRST Robotics. This is the college level of FIRST Robotics. And if you decide, if you did do FIRST Robotics at your high school, you have a chance to get a $5,000 scholarship each year at Temple. I set this up. It's been going on for years. So if you're able to do this, you're going to be able to talk to me, and then we can get your application into Temple to do to get a nice little scholarship. Next slide. Hey, we did well. This is actually right behind where we do the competition, but you can see that's a Saturn II rocket over there. This is a Gemini rocket over here on the left. Every year we get to go down and spend time with the actual in the robot garden. That's where we compete at. And it's truly a heartwarming experience. One of the greatest things that I think most Temple students have experienced. Next slide. All right, just to give you a quick commercial break, I run a summer robotics course for high school students since 1991 at Temple. It costs typically around $550. You get 5 weeks of doing Temple robotics with us. You come down to campus. Now, obviously, we didn't do it last year, but hopefully next year we can. And if not, I'm going to do it online. And what we're trying to do here is to get you, it isn't to sell Temple so much, it's to get you involved in what electrical and computer engineering is all about. So these are some of the students that we had from our course 2 years ago in 2019. It's a great experience. It's inexpensive, and you get to see Temple before you come into Temple. And this is something that's, I think, crucial, that you get to see what the facilities are like. You get to see what our faculty are like, our graduate students and TAs are like. So, and that's all NASA funded. And next slide. Okay, Dr. Budishek, you're out of the batter's box and into.
All right.
Baby.
So really cool there, Dr. Helferty. So I'm going to give just a little demo of what happens inside some of our classes. So Dr. Helferty just gave you some, give you a taste of what happens outside. So I am going to go ahead and share my screen. And let's do this one. And first, I think you guys should be able to, let me just check real quick. You should be able to either type in the chat or the Q&A. And I want you to listen. This is going to be a 10-second video clip. So we're going to play Name That Tune. Okay, so I want you guys to see if you can name this tune, and then we're going to do some stuff to this video clip. So I want you to see if you can do, so it looks like you can chat. So in the chat, anyone know what that clip is? And if you don't know, just put a question mark. All right, Merrick.
Somebody hammered that one.
Good job. That was good. That was very good. So yes, it's Sunflower from the soon-to-be classic movie, Spider-Man Into the Spider-Verse. So, but now what I want you guys to type in, so now what we're going to do is we're going to do a little bit of signal processing. So that's one sort of branch of electrical and computer engineering. And so what I'm going to show you is, this is actually, so you probably all know like tones or are just frequencies of sound, right? And so this is just a plot of different frequencies of the sound clip I just played you and their relative strength, okay? So what we're going to do is we're going to play with this frequency a little bit. And we're going to do something called either a low pass or a high pass filter. And we're going to cut some of these frequencies out. So the first thing I want you guys to go ahead and type in the chat. I'm going to take some takers as to, I want to get rid of that hey, hey sound. So the at the end, I still want that beat, but I want the hey, hey sound. So tell me what I should do, what I should put this cutoff frequency at. So it's either 0 to 2000. And then should I put this low or high? So go ahead and think about that and type it in the chat. So I want low or high, and I want a cutoff frequency. And I'll go ahead and see what you guys come up with. All right, so Mark says high. So who wants to guess a cutoff frequency? So we can try high. And we'll see what happens with this. So we still get that hey, hey, right? And we get the beat, but it's not as strong. So anybody else have any other guesses that we want to try to get rid of that hey, hey? Give you guys 1 minute. This is your first exam at Temple University. You're not doing so hot so far. Oh man. All right. Well, let's try it. Let's just try make the cutoff lower. Okay, yeah. So let's make it lower. So let's see. Let's just make it here. Let's see what it does. Okay, so basically I'll give you guys a hint. So right now we have either a low pass or a high pass filter. That hey, hey is pretty high tone compared to the beat, right? So we're passing that high tone, that high frequency. So let's just go ahead and keep that 400 and let's try low. And you can still kind of hear it, right? But it's not, it's definitely a lot fainter. So what's happening is we're basically cutting off some of the sounds. And this is basically how an equalizer works. And this is something you'll easily be able to build programs like this at Temple University. In a lot of your classes will teach you how. And this is a program called MATLAB. If you've never seen it before, it's a really powerful tool. And we'll teach you how to use these tools and do cool stuff like this. So I just wanted to give you guys kind of a taste of, we're making classes interactive during COVID times, but our classes are also really interactive face-to-face. And it's not just, sitting and listening to people talk the whole time. We make it as interactive and as hands-on as possible. So, so good job. I'll play one more just at a low cutoff frequency just to give you guys an outro. I think this is my favorite. And this is literally what I do all day. I just sit in my basement and I play Eclipse of Sunflower over and over at different frequencies, So if you're like me, you belong at Temple. All right, so I'm going to stop demoing. I'm going to stop sharing. And is Dr. Thompson, are you next?
I'm not sure.
Yep, so I just have to share my screen again. Okay, Dr. Thompson, take it away.
All right, cool. Well, welcome everyone. Thank you so much for stopping by tonight. Welcome to this discussion about Temple University. Thank you, Dr. Halferty. Thank you, Dr. Budashek, for those really interesting demos. I've worked, I'm a senior design coordinator, so I work a lot with senior design students, and I've worked on a lot of those projects that Dr. Halferty mentioned, and the students really have a blast doing those designs. And especially when they get to visit the site. So it's really cool. And then the audio signal filtering from Dr. Budashek, always fun for the students. They even do a audio equalizer design in our circuits lab too. So lots of sort of application design-based work that we're trying to thread throughout our curriculum. Here, I'm going to talk a little bit about some of the things that are additional things going on inside the classroom. Here we have a picture of a couple students working in our new Ideas Hub. The Ideas Hub is our new makerspace that we have newly renovated. It's a beautiful space. Everything is brand new there. We have some very high-end electronics and instrumentation, and it's kind of an open environment space where students can work and do experimentations, whether that's in their senior year while they're doing their final capstone project, or even in their earlier studies, and all the way from intro to engineering in freshman year. They have access to this equipment. It's an open space. It's open from 8 a.m. till usually 5 p.m. or 8 p.m. most nights. Of course, right now there's some restrictions, but we fully expect that when things are back to normal, that this will be a great space for students to collaborate and work and do their hands-on project work. You can go to the next slide. Here's a couple of examples and snapshots of projects that students work on in the classroom. In the top left, you see labeled digital circuits. That's a Basis 3 FPGA signal processing board. And so in this particular example, students are from their digital circuits course using digital logic to encode information and represent information in format on those LED, those 7-segment LED displays. You can see in the upper left, it might be a little bit difficult to see, but it's saying 2017 2017. And so students work on designing all the background logic to take in information. And there's other projects here in this course, including things like IR transmitters and receivers that students work on in that class. On the right-hand side, you have circuits class. So these are pictures of students doing their work inside the laboratory. This is another space that we have, and students get some fun opportunities to build, prototype, and test and measure their results. And so in the circuits lab, a couple example projects that we do right now is we have students design a nightlight circuit. So when the lights in the room turn off, we design a circuit so that a light illuminates when lights in the room turn off. And we kind of use the theory to help drive our designs there. And then another design is a type of filter design, sort of like an audio equalizer, like Dr. Budishek was showing before. Can you go to the next slide, please? Here are a couple other senior design projects that we're working on, or that have been worked on in the past. On the left is what was called a Nectec MIDI guitar sensor. And the idea here was being that trying to sense different types of sounds and help train musicians to be better at making those sounds. And so collecting that data and trying to use that data to help improve the way that you play a particular audio tone in your instruments. And then next slide, please. Some other projects we have on the right, we have a prosthetic hand. So that was meant for training or using for designing different types of procedures for improving your muscular movement in your hand and testing that with the robotic hand. And then on the other side with the glasses and the shades, that was a design where circuits for studying how to improve recovery from lazy eye. So there were studies that shown that young children have difficulties with recovering from lazy eye because the procedures are to cover up your eye and follow certain procedures. So that design was meant to try and help capture some of that behavior and understand how you could improve helping people recover from lazy eye. So just to give you, these are kind of just to show you some of the other projects that students are working on and seniors have worked on in senior design in the past. And next slide.
I can talk a little bit about this slide right here. One thing that we encourage all of our students to do, whether you're an engineering student or in any major at Temple, is to get involved. In all my years working in higher education, I found that the best students are the ones that stay busy and get involved in organizations both within the College of Engineering as well as Temple as a whole. So these are just some of the examples of organizations that students can get involved in at the College of Engineering. You've got Temple Robotics, you have IEEE, which is the Institute for Electrical and Electronics Engineers. It's the Professional Society for Electrical Engineers. SWE, which is the Society of Women Engineers. NASB, which is an example of one of our kind of intercultural engineering organizations, the National Society of Black Engineers. And there's a number of other student organizations within the College of Engineering that we encourage you all to get involved in as well. And then finally, here you can see sort of when you pull it all together, what happens after you graduate from Temple. This is just a very small example of where graduates from the Electrical and Computer Engineering department are working now. As a whole, about 85, I think our last graduate exit survey from last year of 2019, we won't have 2020's results for another couple months or so, but close to 90% of our graduates are either employed or enrolled in graduate school within 6 months of graduation. And engineering students historically have some of the highest starting salaries for all of Temple graduates, which is really exciting. And that's a really great advantage to Temple as well, is that you get a really high quality education for an affordable cost. And as an engineering student, you'll certainly see a return on that investment. And finally, here's just some contact information. If you have any questions after the session is over tonight, any general questions you can send to the email address at the top, ugengr@temple.edu. And at this time, we'd like to take questions from you all. And while you're getting those ready, I'm actually going to turn it over real briefly to Mark, who's one of our students, who can tell you a little bit about what it's like to be a student at Temple and a student at the College of Engineering. So Mark, if you want to go ahead.
Yeah, absolutely. Thank you guys for being here. Like Colleen said, my name's Mark. I'm a senior here at the College of Engineering in the Electrical and Computer Engineering department. So I just wanted to give you guys kind of a brief overview of some of the projects that I've gotten to work on through classes or through outside research, and then a few other things that I've done outside of the College of Engineering. So one of my first major projects that I was able to work on was actually with Dr. Bai the summer after my sophomore year. So we worked on kind of a bunch of cool technologies there. The ones I like to highlight is we worked with a humanoid robot, which is basically just like a small scaled robot that kind of thinks almost and acts like a human. So one thing that we were able to do with that is whenever someone tapped on its head, we had facial recognition software built in that, based on pictures of the people in our lab that we had uploaded, the robot was able to kind of process itself and decide who tapped on its head based on its front-facing camera. And then we ran the algorithm on that. And with a high level of confidence, we were able to have the robot actually speak, like, hello, Mark, for example, if I tapped on its head, or hello, Dr. Bai, if Dr. Bai tapped on its head. So that was super cool. And that project, I believe it's still going on, is working towards kind of a future goal of having it in use in like actual households. So it could kind of walk around your house and, you know, assist you if anything were to happen. Like if you were to fall, the robot could come over and help you. So that's just one example of a super cool project that you guys could work on during the summers or during the semesters. And it's usually almost always paid, which is, you know, a big thing, especially when you're in college. So another thing we worked on in that was we kind of integrated together a Raspberry Pi, a Roomba vacuum, and a 3D sensing camera to be able to remotely steer the Roomba kind of around a different room and have it create a 3D image of that room, kind of steps toward having it be able to autonomously walk around that room. So those were the two major things I did with Dr. Bai. And then actually this semester and the past semester and the semester ahead of me, basically your last 3 semesters in your degree, I'm working with Dr. Helferty on my senior design project. Like he mentioned before, I'm on the high altitude ballooning project. So unfortunately, we don't have an Eclipse this year that we can videotape, but what we're doing is we're using a similar balloon system. We're going to upgrade that system, and then we're going to integrate in some gas sensors onto that system to hopefully be able to measure the CO2 concentration in the atmosphere, going from about, ground level to hopefully up to about 25 miles into the atmosphere. And we're going to do this in, like areas where climate change, or not areas where climate change happened, but, like areas with higher CO2 kind of release. We're thinking maybe Pittsburgh because they have coal mines there, and just kind of see how that's affected with altitude. And then as an add-on to that project, we have a 360-degree camera, and we're going to try and establish a local area network connection between the balloon and a computer on the ground to try and wirelessly transmit that 4K 360-degree video, and just kind of see how much quality we can get with that. And that's something we're really looking forward to, and we're hoping it works out. And so a few things I do besides engineering, because I think it's important that you're not just bound to your classes and your research. You do have opportunities to kind of explore other areas that you're interested in. So for a few semesters, I was a part of the executive board for the Society of Physics Students. And, we just kind of worked on more physics-based projects, less of a focus on engineering. We were able to build a device that could actually levitate small pieces of foam in the air using only sound waves. And then we were able to, travel to the Franklin Institute and present that to young students in elementary or middle school, just to kind of, get them interested in the sciences. And then another semester, I was able to study abroad in Rome. So I kind of, took a semester away from the hardcore electrical engineering courses, and I was able to work with the advising department and, create a graduation plan that still allowed me to graduate in the normal 4 years, while, getting a whole semester to explore Rome and explore, everything that came with that. And then just lastly, as Colleen was actually talking about it a little bit at the end, I'll highlight, where you can go after Temple. So, I mean, I'm only in my first semester of senior year, and I've already accepted a full-time offer with Lockheed Martin for after I graduate. And I mean, the classes that I took here, just helped pave the way for that. And the Career Center was, invaluable with that. So it's definitely super realistic. Going into your senior year, you could already know what's coming next for you, which is super cool.
Great, thanks, Mark. That was really helpful. So again, if any of you have any questions, there's actually a Q&A option that you should see if you hover your mouse over either at the top or the bottom of the screen, depending on where the Zoom controls are. That's where you can type any questions that you may have for our faculty, for Mark, just anything you'd like to know about Temple and about the College of Engineering. While people are getting their questions ready, actually, Mark, if I could ask you a question, what was it? Why did you decide to major in electrical engineering, and why did you choose Temple?
Yeah, sure. So I had always, I guess, from when I was younger, always kind of been, into computers. I was always playing the computer games as a kid, and, into all that. And going into high school, I took my first computer science course, and it kind of just, struck me this is something that's really cool. I enjoyed kind of the logic based aspect of it. And then Temple kind of had a unique major for me. I'm in a hardware and software engineering program that allowed me to kind of use that computer science knowledge and interest with writing software, and then integrate that directly into hardware and electrical engineering and computer engineering, and just kind of tie it all together to create systems that kind of do whatever you want it to do. And I like that kind of freedom you have.
And then why, in terms of kind of why Temple as opposed to some of the other universities you may have been considering?
Yeah, for sure. So like I said, they did have that unique program, but also when I came to Temple on Experience Temple Day, it was very welcoming. And then it's continued to be that way throughout the 5 years or 4 years. So I can say with certainty, when you come to Temple, everyone here is friendly, everyone here is flexible. If you want to take a class that's outside of your major, you can do that. If you want to join a student organization that's outside of your major, you can do that. If you want to do research with the department, you can do that. You just have so many opportunities here at Temple that, I just didn't really hear about happening at other schools. I didn't hear about, students getting research in undergraduate in their second year at really any places but Temple. And that's something that's really worked out well for me. Does that answer your question?
Yeah, absolutely, for sure. It looks like we don't have any questions yet. Any of the faculty, do you want to add anything, any words of advice, anything you'd like as a high school student? What's the best piece of advice you think you can offer these students as they're considering engineering and considering Temple?
Well, I must admit that as a Temple alumni and as a Temple faculty member, just you want to make sure that you get up every morning and enjoy what you're doing. If this is it for you, great. This is what you want to do. If you're passionate, your heart's in it. You heard it from Mark. You heard it from Corey. Dr. Bai has been a student of mine. I was his mentor slash tormentor years ago, but I'm very proud of him. But Temple has a very fond place in my heart, and it's my son has just finished at Temple. My daughter is a senior at Temple, and it's just been. I think if you cut all of us, we're all going to bleed cherry and white. As Mark said, it's access. It's access to the faculty and to the facilities, and that's important because now you're not only going to a classroom environment, but you're going to a laboratory environment where you're working with other grad students, undergrads, and TAs. And that is really, I'm finding it's one of the most important things that I'm getting. When you saw the slide that Colleen had up for people that go on a SpaceX, Lockheed Martin, those were students that came through the RockSat and the robotic mining competitions. They've had offers from there. They're working there. And it's just, that's where you get that opportunity on your resume builder, is to put in not only, okay, I have a 3.59 GPA or something, but I also have this other experience behind me where I had to go through all these design procedures that other undergraduates don't have to go through. But this is where you get it. This is where you get that resume builder that bang, it pops out in front of a recruiter and says, okay, this person's got experience in this. I really need to contact them. So my whole point here is that get involved in extracurricular activities. That's important. That shows that you have the drive, the initiative, and you're going to learn so much more outside of the classroom. You're applying all that stuff. Not that we don't apply things outside the classroom. My processors class, you get shipped this board. So it's not like we're going to do simulation over the next 14 weeks. You're going to be working with physical hardware. We ship this to your house, and we're going to be turning on ultrasonic sensors, light emitting diodes, ping sensors, infrared sensors. And this is what we do at Temple. We make sure that we get the technology out to you during even this COVID thing. And that's important. And I want to thank Dr. Bai for being very supportive in helping us do this. It's really important that we get this done. Thank you.
So I want to echo what everyone is saying. So the important thing of Temple University, especially in our department, we're not a big department. We have about 15 full-time faculty member, and they're all come from top-notch school. The people come from Duke University, Georgia Tech, they graduate from there. And so we have top-notch faculty, and the most important thing, they care about the students. Through this COVID situation, I know Dr. Harford is asking so much to say how we can reduce students' fee so they will be able to use those equipment. So this is the type of the faculty you say that care our students during this COVID situation. So I really appreciate those are wonderful thing we're saying right now. And so especially look at some demonstration. I know Dr. Corey Bodishek is teaching for the freshman course. Dr. Brian Thompson is teaching both sophomore and senior year course. Dr. Corey Bodishek is teaching junior year course. I'm also teaching a sophomore year course. So all of our faculty care the students. So that's something is very difficult to get from other school. You're going to be one of the student in like few hundred students in a big classroom. But in here, you can almost go to any faculty's office, knock on their door. We don't have closed door policy, so most often you just knock at the door and the door is open. Just pick your head in, saying what type of research you will have. And the other nice thing about it is I think almost all the full-time faculty member, they all have research projects. So you can ask them to say whether you can participate in the research project. Okay.
Okay, thanks, Dr. Bai. Looks like we did have a couple questions come in. One from Joshua, advice for a transfer student that's coming in next semester. I would say, Josh, if you haven't already, make sure to schedule an orientation session. There should be information about that. If you've been accepted, there's information included about that in your acceptance letter, how to confirm your seat and such. But if you're interested more in learning about your transfer credits, I'm going to put the name of an individual to contact, Dr. Sean Fagan, who's our Assistant Dean for Undergraduate Studies. He works with our transfer students in developing their plan of study and making sure all of your credits, the appropriate credits can come over and you've got a good kind of path to graduate. So I'll put it's S. Fagan at Temple. I just put it in the chat there for you. And we have another question that came in through the Q&A. What are some of the best things that Temple will do for me to help me succeed in engineering? I think a lot of people kind of answer that in their own way kind of throughout the session, but did anyone want to add to that, Kyle's question? Mark or Dr. Bai?
I would add colleges has this summer program. If you have a GPA 3.0 or above, you can work for 10 weeks during the summer. That's what Mark goes through his summer program. So once you got this type of skill set, and then we know what type of skill set you will have. So we have our connection. So sometimes we can recommend you to work in industries. For example, another student of mine worked within one summer. The next summer, he started working in Comcast. And then before he graduated, and he's already have a job offer, just like Mark was describing. So that $4,000 is a great, and because a lot of time the student finish their freshman year or sophomore year, and they don't have any experience, so it's very difficult for them to find a job. But if they are able to work in a research lab, gain certain skill set, that would be really great. And that means next time you can do a summer intern. So I think almost all the students finding full-time job, they will definitely get a full-time positions after the internship.
So I just wanted to add in there real quick, since I do teach the intro to engineering classes, I see a lot of new students come in. And I think one thing that Temple does really well is they have a really nice free tutoring service that a lot of students take advantage of. And they also, like we've said, is you have close contact with the faculty members. And I think that's key to any university you want to look at, is that, you know, we care about you. We care about your success. You are not just a class we have to teach because we were told we had to teach it. We care about our students wholeheartedly. And so I think the big thing I would tell new students coming in is to make sure that if you're having difficulties with anything, you reach out to the faculty, you reach out to the tutoring center, the advisement center, because when you find that you reach out, you're going to find an open arms and an open hand to help you out with whatever you need. So that's always my biggest pitch, is that advocate for yourself, and you'll find that people will help you, hopefully more than you'd ever expected.
Yeah, absolutely. Just to highlight like what Corey was saying and what I was saying before, like it really is just like whatever you want to do, like Temple will find a way to make it happen. Like I'm confident, like any of the presenters here today, like Dr. Bai, Corey, Dr. Helferty, Dr. Thompson, like I could walk into any of their offices or maybe stop in their Zoom room during COVID, and like any of them would be willing to help me kind of, you know, make a path for whatever I wanted to do, whether that's a senior design question or whether that's a research question. And I mean, that's true of all the faculty here. And that's true of advising. Like I've emailed, you know, Sean Fagan so many times being like, this is my schedule. This is what I need to happen. How do I make it happen? Or just the other day, I emailed him about like, look, I have an open course slot next semester. You got any ideas? And like immediately I got a reply with 4, you know, graduate level computer science courses that he thought would be interesting to me based on like the 10 conversations that we've had before. And I really don't think that's something you can get at other schools. And like, I haven't like heard from anyone else at other schools that that's something you can do. It's a super open, flexible, welcoming atmosphere that just allows you to kind of choose your own path, whether that's studying abroad or whether that's, you know, doing research during the semester. There's just so many options that are pretty much all open to you.
Yeah, I just want to echo everything that our faculty and that Mark have said. You know, I've been at Temple now almost 3 years, and I can definitely say that the amount of opportunities that will be available to you as an engineering student are really, really special. I mean, you know, Mark's a good example in that he was able to study abroad and do research, and now he's got a job waiting for him. I think it would be difficult to come about just getting all of that experience in 4 years anywhere else. And again, even though Temple's a large university, the College of Engineering is a small college. So you'll get, again, all of the benefits of being at a large urban research university, with the best of both worlds being at a smaller division within that. You know, really great access to top-notch faculty who are really truly committed to teaching and mentoring. And it also looks like we haven't had any other questions come in, so I am going to stop the recording. This will be sent out and available on our website probably within the next couple days or so. So if you ever need to refer back to this at any point, don't hesitate to just give it a watch, or please just email us if you have any other questions as well. But again, I'm going to stop the recording, but we can stay on if there's any additional questions.
Summer robotics, please.
Yes.
Summer robotics. This is for you high school kids. You build this, all right? Ultrasonic sensors, Arduino microcontrollers. Come on in. I'm giving you a pitch, all right?
And you can see Dr. Helferty's email address right there. So please
Got
get
it
in
up
touch with him
there.
if you're interested.
And we go for 5 weeks over the summer from Tuesday through Thursdays, but it's a great, I've been doing this since 1991, and it's not only students that go to Temple, but go anywhere. You get an opportunity to get a taste of what electrical and computer engineering is all about. And again, it's for your benefit to experience it. I've had students that said, this is great, I'm going on. And I've had students to say, Doc, this isn't happening. Well, guess what? You didn't have to go through a whole freshman experience somewhere and do electrical and engineering or mechanical engineering or whatever. You have moved on. So take the opportunities, not just my class, but look out there for summer classes wherever you can that give you a taste of what engineering is about. And if you like it, great. And if you don't, move on. Get up and find out what you want to do in your heart every morning. So that's my advice.
And Colleen, if it's